Ollie at DU on campus has their own little catalog.
Oh, okay. Because I know when I go online, because I always do it online, I know I've gone online, you have to pick and choose.
Yeah, I
look
think there
at
are
it.
5 different catalogs now.
Oh, wow.
Ollie East and Ollie South, and I think each one has their own list.
Mhm.
But Ollie Central has, I don't know, 60 classes or
It's
something.
huge.
It's a lot. Did you bring my books back?
No, but it's only.
Oh, okay. This is what I read now.
What's that book, Steve?
The Great Equations.
I see that first one?
Yeah. It's about,
Yeah?
it's science stuff.
Yeah, it is. This is the one right there. When I had this, I don't know if you're familiar with that. That's the one.
The entropy.
No, I'll write it on the board if we ever use it.
Oh, yeah, that's
Oh, steal it.
E to the I pi plus 1 equals 0.
He likes it though.
Yeah.
Where's Lisa?
I knew she wasn't gonna be here today. She said so yesterday,
Oh, yeah, that's right.
but I don't know where she is.
It doesn't have the East. I have a lot of East classes.
Might be a few in there.
Not
Mostly.
East, no East. It's got Faro and Park.
I can go down and get one downstairs if you don't have one. Oh, you got it.
So we have a few topics to talk about. I guess we're ready. We got a few seconds to go. Let me take this pen back and we'll start.
There's so many things to understand in life that I don't.
I'm looking at that one and like, oh, man.
Like, how come you can see through glass and you can't see through aluminum?
Maybe you need to know. One of the reasons is glass isn't a solid, it's a liquid.
Yeah.
All right, let's start. So, let's see, we'll start with something Bob brought in, that some of you may want to look at. 2 articles from the New York Times Tuesday. New York Times on Tuesday is Science Day. And these are 2 articles about the moon, one about the Chinese lander that's on the far side, not the dark side. We should all strive. I have pet peeves. One is people, including the New Yorker magazine, referring to this orb that we live on as the Earth. I don't know. I've written to the editor a couple of times about this. We do not say the Mars or the Venus when we refer to the planets. This planet is called Earth and it has a capital E, and they insist on writing the Earth with a lowercase e. There is a use for the word Earth with lowercase, and that is when you're digging in your backyard. Dirt. Anyhow, far side exploration by the Chinese, and then a moon of this planet, Earth, that is orbiting just like the commonly known moon, except this one is the size of your bedroom. So, if you have access to the Tuesday Times, or you want to take a look at these, let's see, Steve's reading a book about mathematics. He seems There's no end to his curiosity. And it's a book about the famous equations of mathematics. And this is the one. For those of you who are not math people, this is a special number. It's about 2.7. It's used in every field of science, including economics and your bank account. It's related to how interest accumulates in your bank account. E. I is the square root of -1, which is unreal. Because it's not, I mean, the square root of -1 in normal commerce does not exist. But in engineering and science, it's an extremely powerful concept. And then pi, the plus sign, and the number 1, and you put this all together and you get 0. This was an invention of famous Swiss mathematician Leonhard Euler, the father of a whole community of descendants who were mathematical geniuses. Bernoulli is another one. It's like the Bach family, except for math. So this is usually referred to as the most famous equation in all of mathematics. Freeman Dyson died this week, at the age of, I think, 93. Freeman Dyson was an eminent mathematical physicist, and he never obtained a PhD, but he became a member of the Institute for Advanced Study in Princeton, New Jersey. It's not affiliated with the university. It's funded privately. It's existed since the mid-30s. Einstein was there for a long time. Freeman Dyson was there from 1953 until he died. He actually fell at the Institute. Today is Thursday. I think Monday he was at work and fell, and complications ensued, and he passed away. He did many, many things, and his children are very active. Esther Dyson, his daughter, is very prominent in the modern environmental movement, and she's a filmmaker. But for me, his biggest achievement was this. In the late 1940s, 3 people were prominent in developing a thing called quantum electrodynamics, which is something I've mentioned in here before. The interaction, it's all about a very simple thing, the interaction of light and electrons. And it's like all the fields of science, or perhaps every field of intellectual endeavor. If you really dig into it, it's really, really complicated. So a simple thing, how light interacts with electrons. 3 people were working on this problem. Richard Feynman, who some of you may have heard of. Julian Schwinger, who was a genius from the time professionals recognized him as a genius from the time he was 14 years old. And Tamanaga, who was in Japan. This is all happening right after World War II. They're all independently working on quantum electrodynamics. And of those of you who are interested in just the history of physics, there are lots of books about how these 3 people independently developed their concept of how light and electrons interact using very different techniques, mathematical techniques, that required bravery. Because to get the result, to do a calculation about electrons interacting with light, all the calculations lead to infinities. And you have to be a brave, intrepid scientist to say, I'm going to get rid of the infinities. I'm going to figure out a way to eliminate these things. And the little tiny dust that's left over after you do that is a number. It has to do with the magnetic properties of electrons. And so these 3 guys working independently, and including Tamanaga, who was hiding out in Tokyo during the bombings in World War II, trying to not get dead, managed to stay focused, and he, as soon as the war was over, published a result. Schwinger, who, as I say, was a genius from the time he was a child. He grew up near Columbia University in New York City, and he was just hanging around the physics department, and people would say, go find Julian, he'll know how to do this problem. He wasn't even a student there. He's an extraordinarily talented person. And Feynman got famous. He worked on the Challenger accident. He was on the board, the accident review board. Anyway, here's how this connects with Dyson. 3 guys, independent techniques, and they produced an estimate of something called the anomalous magnetic moment of the electron by throwing away infinities in a very clever, each in their own way. And Freeman Dyson, who had just graduated with a master's degree at Cambridge, was intrigued by how it is they all 3 got the same number using different techniques. And he committed to understanding each technique so well that he could understand what they did. Because, and there are videos of this, where Feynman and Schwinger are standing at a blackboard, and one is saying to the other, show me how you did that part of the calculation. And it's like me speaking to somebody who speaks Chinese. There's nothing going on. All the words were in English, but the techniques were so different. Freeman Dyson figured out that all 3 techniques were equivalent. He had to master all 3 strategies. And just amazing intellectual achievement. Now, the 3 people I mentioned went on to win the Nobel Prize for their work, 1965, perhaps. Freeman Dyson did not win. There can be only 3 winners for a particular prize. But the community, that community knows, of his intellectual achievement. So now I have personal contact with Freeman Dyson. A friend of mine for years was the leader, the organizer of something called the Jasons. I think I mentioned Jasons in here once before. Jasons was formed by the Department of Defense starting maybe in the early 50s. They would find a community of scientists, and they bring them together for the summer in some kind of interesting location and throw a bunch of problems at them and see if they could invent solutions. One of the things they worked on was adaptive optics, or synthetic guide stars, which I talked about last week, the technique so that ground-based telescopes can image almost as well as space-based telescopes. That was a Jason invention. So my friend Bob ran this program and organized the meetings. The meetings were held most recently in San Diego. So they put these people up in homes, and they have a nice work environment at a company called General Atomics in San Diego. So one year, Bob invited me to the kickoff party, which they would have a cocktail party every June for the Jasons. So I went to this thing, and it was just a room full of Nobel Prize winners and me. And so I was wandering, I had my little glass of wine, I was wandering around, nobody knew me except my friend Bob. And a small woman came up to me. She appeared to me, the first vision I had of her, she looked like a bird. She was absolutely as tiny as you can possibly be in every dimension. Just a microscopic person. And she came up to me and she said, I don't know you. Who are you? And I told her. And she said, well, what was her name? I'm Estelle Dyson. I've forgotten her first name. She said, I'd like you to meet my husband. And there was Freeman Dyson. Also very small and bird-like. How many of you have seen a picture of Freeman Dyson? Anybody? Take a look. He's in the news because of his obituary. He had a tiny little head and a spectacularly huge nose. And a spectacularly huge brain. And so I shook hands with Freeman Dyson, and I was telling a few people as the class was getting ready to start. you could see, he was tired of his wife doing this. She would find people who seemed to be wandering around at parties or whatever, some kind of event, and make sure that he met them, and he was not interested. He just didn't care. But he was really an intellectual giant. And he and Richard Feynman, who's a character, met at Cornell University probably 1948, and they drove to the California Institute of Technology together. Drove across America on, 2-lane roads. And Freeman Dyson wrote a book about that experience of traveling with Feynman and what they talked about. He's a really interesting character. So today is our last meeting. Thank you for attending. I'm disappointed today because my daughter was supposed to attend, but she was waylaid by a flat tire. So maybe she'll show up halfway through.
Just out of curiosity, do you know a name named Marvin Goldberg?
Yes, Goldberger.
No.
The one I know is Goldberger.
This was the chairman of physics at Syracuse University.
I don't know of that person.
Oh.
I don't think.
He doles out hundreds of millions of dollars through the National Science. He's a key fellow in that.
Oh, in National Science Foundation, like in the grant
Yeah.
program? No,
I asked because he's my neighbor. My neighbor.
oh, wow. We should hang out sometime. We'll buy some beer and invite me over.
He went to Bronx Science and I went to Stuyvesant.
All right.
Both friends.
So today's last lecture, I want to do a couple things. First of all, I want to encourage you to ask as many questions as you'd like. I have material with me pertaining to unresolved issues in cosmology. That's the focus of today's talk. But we can talk about anything you want to talk about, things that pop up. Let me also remind you that the videos I've produced in here are available. They'll stay up. The lecture notes will stay up. If it occurs to you to mention this class to others, do so, because there's no classes during the summer, I think.
Correct.
I might be teaching again in the fall. We'll see what the reviews look like. But I'll be living closer. I'm moving in September to Stapleton, just a little closer. I live in Broomfield now. Okay, so let's get started. I'm going to show you some questions that have been asked in prior classes that I thought might stimulate some conversation, and we could go through these. So one of my former students asked, can wormholes exist without being connected to black holes? In one of these talks I mentioned that there's this idea that's floating around that if you can create black holes with something called entangled particles, you can make a wormhole so that there's a pathway from place to place in space. The answer is we don't know about any of this. There's speculation, and the calculations allow Einstein's. If you use Einstein's equations, you can conjure up a way to create to create wormholes. But this is highly speculative. And I have a note here to see Kip Thorne's book called Black Holes and Time Warps, because he does discuss this at some length. In fact, he, in maybe the late 80s, he and one of his students published a paper on the topic of wormholes and said, hey, look, there's a way that Einstein's equations are consistent with a shortcut through space-time, where you can go from place to place instantly without having to travel in the space we're living in now. And this was published in a refereed journal, and the community of metaphysical people got a hold of that, and for a while it was a thing. He was embarrassed because he gave fodder to non-scientific interpretation of whether wormholes can exist, or can you pass through them. So that's one thing. The second thing here is about exoplanets. What do we know about them? And the answer is we know a lot. about a few of them. First of all, we have thousands of exoplanets that have been found, and some of them happen to be in the orientation of the solar system they're in is such that we can learn about the mass and the orbit properties and whether there could be liquid water. And there's an army of people crawling through the data that's been collected from space missions. The Kepler mission is a notable one in this regard. The data is public, so you can get online and play around in there and see if you can find it. And people are doing this. It's not just professionals. So there are occasionally a student will find a planet by cruising through the data. So we know a lot, and there's more data coming. The Europeans have a new planet finder that's functioning. James Webb Space Telescope will also be a planet finder. So some of that's going on. Somebody then asked about the Arecibo. Some of you may have seen this. It's a giant, looks like a salad bowl built into a mountain in Puerto Rico. And it looks straight up. It's a radio telescope. And the Chinese have their version, which is stupendously huge. It's the size of the campus here. It's 500 meters in diameter. And the question was, do these things, are these still relevant? The answer is yes. These are giant radio telescopes, and radio astronomy is alive and well. I mean, it could always use more support, but there's a big future in radio astronomy. And the last one on this page is, could small ground telescopes be grouped to extend, to make them more powerful? And we have talked about this, where you could have a collection of telescopes working together to form something called an interferometer, and that synthesizes a telescope of that size. Let's say if you cover a mountaintop with telescopes, you can make that behave like a telescope the size of the mountaintop, even though you haven't covered the top of the mountain with telescopes.
You've shown us pictures of those.
Right. The Very Large Array in New Mexico, which is a radio, a interferometer working in the radio frequencies, has been very successful. It definitely needs help, though.
Question?
Yes?
Can radio telescopes like the Arecibo one look anywhere other than straight up?
They can. There's some amount of steering that they can do electronically, because the telescope cannot move. It's rooted to, and it's being, I think, restored because the hurricane, I don't know which one, really wreaked havoc with it. But it can steer electronically, and then it has trying to think, if some of them have a bridge that goes across the whole of the salad bowl, and it has a receiver on that can be moved, and that gives the effect of giving you some steering.
Why was it built in Puerto Rico?
It was a good location, low radio background. It's in a rural spot in a basically rural country. And you want as little interference as possible. I think that was a big factor. It's also possible that was political pork. For example, there's a big radio telescope in West Virginia, the one at Green Bank, West Virginia, that is there because Robert Byrd was the senator, and he wanted to, this goes on all the time. There's a reason the Space Telescope Science Institute, where they run the Hubble, is in Maryland, because, once again, a small person, a senator, lady senator, she's about this tall, she worked very hard to make Maryland a center of space excellence. So anything that could be directed to the Goddard Space Flight Center, which is in Maryland, that was a good thing. Money to the Air Force, to the Naval Academy, money to the Space Telescope Science Institute. So political factors. A great place, speaking about the Chinese and the moon, the far side of the moon, a great place to do radio astronomy is on the far side of the moon. Because the moon itself blocks out the radio signals from Earth, and it's There's a lot of interest in building a permanent